Okay, I want to introduce you to chemical equation. Now, most of the time, I'm going to give you the unbalanced equation. I want you to, from now to the end of the semester, assume every chemical reaction I give you is unbalanced. So you got to make sure it's balanced. Okay, so again, we have reactants. Now, I'm going to stress again, what happens with the reactants to go to product? The reactants bonds will be broken. And they're going to reform into new combinations in the product. That's why all reactions require a little bit of energy to get going. And that energy is to break the bonds of the reactants. For example, we're going to learn stuff at 5. You throw the log down, they automatically spontaneously do a flame. What do we have to do? What? Yeah, that's the energy to break apart the wood. What we form with the polyethylene now. So every reaction requires energy to spark. That's the fancy word for that activation. Okay. Okay, so reactants, bonds break, products, bonds form. Okay. Okay, so we're going to take methane, which is the main gas, and we have a gas stove at home. Methane is the main gas. There's a mixture of gases, but methane is the main. When I add some oxygen to it, oxygen gas, I'm going to create carbon dioxide and water. Now we have to assume this is what this equation is stating. Unbalanced. So we always check to see if it's balanced. If it's not, we balance it. So the first thing we're going to do, we're going to take an inventory of all the elements. Okay, we've got carbon, hydrogen, and oxygen. We are not going to create an element or destroy an element. So what we start with, we're going to end with, only rearrange. Okay, so how many carbons do I have on the left? 1. How many on the right? 1. So we have a balanced carbons. Let's go to hydrogens. How many hydrogens on the left? On the right? 2. We got a problem. How many oxygen on the left? On the right? 3. Again, a problem. So this is officially not balanced because the inventory on the reactant side does not equal the inventory on the product side. They have to be exactly even. So remember we have coefficients out in front of the molecules. That's the numbers we can change to balance. So do you have any ideas what coefficients we can change to make this? Look at the hydrogens. We got 4 on the left. What can we do to the water to make it 4 hydrogens? We'll find to work with a coefficient of 2. Okay, so that changes our hydrogens to 4 now, because 2 times 2, 4. But it also changes our oxygens. Now we have 2 oxygens and 2, we have 4 oxygens. Now we go to the other side on the O2 side, and what can we put in front of the O2 to make it 4? 2. Now it's balanced. And I call this an inventory. basically just doing element inventory. What's on the left, how do you know what's on the right? So you're gonna have stored memory funds. We just did one a little while ago. All stored memory funds have 4 steps. Step 1 is to balance the equation every single time. It may come balanced, but you got to check it to make sure it's balanced. The second step is what's given. The third step is what you're going to calculate. And the fourth step is the setup. Okay. So let's do another one. Is everyone okay with this so far? Let's take
So the coefficients.
only the coefficient, not the subscripts. We change the subscripts, it's a different molecule. So all we're doing is we're changing the coefficients, which says how many of those molecules we have. Okay, so we're going to take my butane lighter, C4H10, and I'm going to light it. I'm going to get that started for that activation and get this oxygen combined with the butane. So again, the butane, the C4H10 can break apart and combine with the oxygen and reform to form carbon dioxide and water. Okay, we need to do inventory. CHO. All right, carbon's on the left. On the right. Okay, so right away we have an issue. Hydrogens, 10, 2 on the right, 2 oxygens, 3 oxygens. So this thing is all messed up. So where do you want to start? Carbons, okay? So if we put a 4 here, that gets our carbons 4 and 4, but that also changes our oxygens. Okay, we have 4 times 2 is 8, plus 1 is 9. Okay, we're on hydrogens. What do you do about hydrogens? That's the only place you can put a number is in the front. Now, okay, let me make sure you understand. This says 4 molecules of C4. We have 4 O2 and 4 carbon. That's why we have 4 times. Okay, what do we do about the hydrogens? Okay, and that changes our oxygens again. So we have 8 and 5 is 13. What are we going to put in front of the O2 on the left? Two times what is 13? There's a fraction. What fraction you multiply 2 by to get 13? Okay, is it balanced? 4, 4, 10, 10. 13, 13. Okay, now it's balanced, but we have a problem. Problem is flat. Okay. Going back to what a balanced equation gives you. Balanced equation gives you the number of molecules, the number of moles. So you have a fraction of the molecule. So you're going to clear the fraction. Most of the time, like probably 95, 98% of the time, you're going to be clearing out 2. If you multiply everything by 2, go away. So,
Just reactants or products also?
think about this as an equation. So, all the way across. Okay, so 2 times 1 is 2. 2 times 13 over 2 is 13. 2 times 4, 8. 2 times 5 is 10. Now we have no fractions. So I want you to balance it first. You have to use fractions, that's fine. And then clear the fractions out. Let's see, let's do, okay. So we have cupric chloride plus sulfuric acid gives us copper. Okay, so look at inventory to see if this thing is balanced. Here we have copper, chlorine, hydrogen, sulfur. Oops. Huh? So we have copper, chlorine, hydrogen, sulfur, oxygen. Okay, so we have 1 and 1 on the copper, 2 and 1 on the chlorine. Hydrogen is 2 and 1. Sulfur is 1 and 1. Oxygen is 4 and 4. So it's not balanced because the numbers aren't equal. So going down the list, what do we do about the chlorine to balance it on the right? Put a 2 in front. Okay. And it's balanced. Now some of these are going to be okay, I want to show you one other way to work this problem. If you have a SO4 ion on both sides, instead of splitting up the SOs like this, SO. How many SO4s? How many SO4s on the left? 1. On the right? 1. Okay. So you eliminated all those S's and O's to count. So you're counting them as a group. They are no longer a single S. They are no longer O's. SO4 group. Now, to do this, that's up there on both sides of the equation. You can also split that. One, usually this is a little simpler. The concept is the same. How many S4s in the left? How many S4s in the right? In this case, it's 1 to 1. Okay, so let's do some practice. What I'm going to do is I'm going to pull up a worksheet. Now, under files, these are all the files I gave you. lots of practice. So let's pull up equation balancing. So why don't you, let's do 4 of these tonight. And then the answers, all I want you to say, the answers are. This is tricky. This is what. This, the technique is called guess and shift. It's not an analytical method at all. However, I do have an analytical method to make matrices. You can form a system. Using
One. And then it's on.
Yes. Okay. The check mark in the inventory. This is where we're going to go. We're going to have
No, it doesn't. That should. So you have. One, two. 4x4 matrix. Oh, I thought you were saying like 4 weeks. So the answer keys for this are on Canvas as well.
It's set the next page down. Well, there's another one named answers. Oh, right here. Yeah. But I always have the answer for it. Oh, Class, I'm going to do an extra credit problem. balancing. And I forgot whether I put it on canvas yet or not. I think it's called extra credit. And then the extra credit, obviously. I don't know, what's wrong with it? All right, see you later.
Thank you.
Good Thursday.
Yeah, so there's also SO4.
Right, and that's the four, so how many you have here? This is not four. It's not the same as the other. It's the grade. Those are always my cup. Some people say that's text. That way, you can mix up.
So it has NH3, and then on the other side it has two hydrogen. Would it make sense to put 2 in front of the NH3 and 3 in front of the water? I know. I like to figure out what goes there. Protect the that. But that's gonna be a remake. First aid thing. No, not that.
4 meters. Goal is